students. In today's video we will be talking about graph searching of artificial intelligence. Graph searching. In this section we abstract the general mechanism of searching and present it in terms of searching for paths in directed graphs. To solve a problem, first define the underlying search space and then apply a search algorithm to that search space. Many problem-solving tasks can be transformed into the problem of finding a path in a graph. Searching in graphs provides an appropriate level of abstractions. Abstraction within which to study simple problem solving independent of a particular domain. A directed graph consists of a set of nodes and a set of directed arcs between nodes. The idea is to find a path along the idea is to find a path along these arcs from a start node to a goal node. The abstraction is necessary because there may be more than the abstraction is necessary because there may be more than one way to represent a problem as a graph, whereas the examples in this chapter are in terms of state space searching, where nodes represent states and arcs represent actions. Future chapters consider different ways to represent problems as graphs to search. Formalizing graph searching. A directed graph consists of a set n of nodes and a set of number one a set n of nodes and number two a set a of ordered pairs of nodes called arcs. In this definition, a node can be anything. All this definition does is constrain arcs to be ordered pairs of nodes. There can be infinitely many nodes and arcs. We do not assume that the graph is represented explicitly. We require only a procedure that can generate the nodes and arcs as needed. The arc n1, n2 is an outgoing arc from n1 and an incoming arc to n2. A node n2 is a neighbor of ni, n1. If there is an arc from n1 to n2, that is if n1, n2 that is to equal to a, means I don't know the value of this symbol, means the e like symbol, so I am telling it means that it has some connections with a. Note that being a neighbor does not imply symmetry because n2 is a neighbor of n1 does not mean that n1 is necessarily a neighbor of n2. Arcs may be labeled, for example, with the action that will take the agent from state to another. I am again telling there is an arc from n1 to n2, that is if n1 n2, I don't know the value of this e-like symbol, so it has some connections with a. Note that being a neighbor does not imply symmetry. Just because n2 is a neighbor of n1 does not mean that n1 is necessarily a neighbor of n2. Arcs may be labeled, for example, with the action that will take the agent from one state to another. A path from node S to node G is a sequence of nodes n0, n1, nk such that S equal to n0, G equal to nk, and ni equal to ni, means ni hyphen to 1 ni, that I don't know. I have already told that I don't know this e-like symbol, so I am telling it has some connection, so means it has some connections with a. There is an arc from n1, that is hyphen to 1, means n1 means ni, sorry friends, ni equal to means ni hyphen means ni hyphen 1 to ni for each. That is number 1. Sometimes it is useful to view a path as the sequence of arcs number n1 means n1 n1 n2, and many numbers means many sequence of arcs nk hyphen 1 nk, or a sequence of labels of these arcs. A cycle is non-empty path such that the end node is the end node is the same as the start node. That is, a cycle is a path n0 n1 nk such that n0 nk equal to 0. A directed graph without any cycles is called a directed acyclic graph DAG. This is the full form of this. The full form of DAG, I am again telling, means directed acyclic graph. This it is written in bracket to means represent you what is DAG. This should probably be an acyclic directed graph because it is a directed graph that happens to be acyclic, not an acyclic graph that happens to be directed, but DAG sounds better than ADG. That is DAG. A tree is a DAG where there is one node with no incoming arcs and even other node has exactly one incoming arc. The node with no incoming arc is called the root of the tree, and nodes with no outgoing arcs are called leaves. To encode problems as graphs, one set of nodes is referred to as the start nodes and another set is called the goal nodes. A solution is path from a start node to a goal node. You can see the diagram. That is figure 3.2, a graph with arc costs for the delivery robot domain. Sometimes there is a cost, a positive number associated with arcs. We write the cost of arc ni nj and cost ni nj. In bracket it is written to means represent you. The costs of arcs includes a cost of paths. Given path p n0 n1 nk, the cost of path p is the sum of the costs of the arcs in the path. Cost p equal to cost n0 n1. It is a portion of cost, that is cost in that portion is nk hyphen 1 and nk. An optimal solution is one of the least cost solutions, that is in a path p from a start node to goal node such that there is no path p from a start node to a goal node where cost p equal to greater than where cost p is greater than cost p. Cost p means in the right side cost p is more than the left side cost p. In many problems, the search graph is not given explicitly. It is dynamically constructed as needed. All that is required for the search algorithms that follow is a way to generate the neighbors of a node and to determine if a node is a goal node. The forward branching factor of a node is the number of arcs leaving the node. The backward branching factor of a node is the number of arcs entering the node. These factors provide measures of the complexity of graphs. When we discuss the time and space complexity of the search algorithms, we assume that the branching factors are bounded from above by a constant. The branching factor is important because it is a key component in the size of the graph. If the forward branching factor for each node is b and the graph is a tree, there are bn nodes that are n arcs away from any node. So friends, now I am ending my video. Hope you understand this video. It is a little difficult, but hope you understand this video and graph searching in artificial intelligence. Thank you friends, and please like, subscribe and comment in this channel and in this video.